composition of trig functions with two different functions. So all the other problems that we just did in the previous lesson, they both had cosine and inverse cosine, or tangent and inverse tangent. They were the same. They were just inverses. Now we have cosine of inverse tangent. So start on the inside, order of operations, start here. If you can do this problem, great. But in this case, inverse tangent of -3/4, that's not one of the ones that we have memorized. So what I'm going to do is draw a picture. Now, inverse tangent is negative in quadrant 4. So that means that this is a -3 and this is a 4. You can use the Pythagorean theorem, or you can remember, oh yeah, it's a 3, 4, 5 triangle. So this is my reference angle. Now I want the cosine of that angle, and so that's going to equal 4/5. This problem, inverse cosine of sine of pi thirds. I can do the sine of pi thirds. Sine of pi thirds is equal to the square root of 3/2. So then I want the inverse cosine of square root of 3/2, and that is equal to pi sixth. Inverse tangent of 5/12, not one of the ones that we have memorized, so I'm going to draw a triangle. It's positive, so it's in quadrant 1. Tangent is 5/12. 5/12, 13 triangle. Again, if you don't recognize that, you can do the Pythagorean theorem. But then we want the sine of that angle. So the sine of that angle is going to equal 5/13. So these are examples of problems where you have different trig functions and inverse trig functions. They are not the same. In addition to that, they're going to give you the same kinds of problems, but they are going to have variables. So these you need to draw pictures, okay? So inverse sine of A, who knows what that is? For all of these, you don't have to worry about the signs. You can just put them all in quadrant 1. So every triangle I'm going to draw like this. The sine is A, and technically it would be A over 1. So A over 1. So you need to do the Pythagorean theorem. Now some of you will be able to do this in your head, but otherwise I have this side squared plus A squared equals 1 squared. So if I'm solving for this side, I subtract A squared and then I take the square root of both sides. And again, we're not going to worry about signs, because can you have a negative length of a side? Technically, if it's in a different quadrant, you can, but we're going to just go with all of the, because whatever this sign is, that's going to change everything else. So we're just going to go with the principle of the positive, and this is going to be 1 minus A squared. So you take what's on the inside, you draw your picture, and then again, this would be my reference angle. So the tangent of that is going to be A over the square root of 1 minus A squared. And of course, we're not done because there's a radical in the denominator, so I have to rationalize the denominator, and I do 1 minus A squared. I do the same radical on top and on bottom, and I get A times the square root of 1 minus A squared over 1 minus A squared. And they can use whatever variables they want. That one used an A, this one is using an X. So I start here. The cosine is going to be X over 1. Cosine is X over 1. So again, you can do the Pythagorean theorem. This is going to be 1 minus X squared. You can write it out if you need to. And then I want the sine of that angle. Well, I'm going to have opposite over hypotenuse, and because my hypotenuse is 1, it's just going to be equal to the square root of 1 minus X squared. So no extra work to do on that one. Same type of problem, but the sine is equal to x over 1. So very similar triangle, and you'll notice that they do this a lot, except for my sine is x over 1. So this side is 1 minus x squared. Now I need the cotangent. The tangent would be opposite over adjacent. So my cotangent is adjacent over opposite. No rationalizing to do, and I am done.